particular thing, what we are doing is we held a meeting at the department level. We invite all the faculties to come up. Timetable બનેલું હોય એટલે faculty ને share કરીએ. Faculty will go through the curriculum and will find out what additional things or what exercises or what additional activities we shall do, so that the actual purpose of teaching that particular subject would be satisfied. એટલે એના બેસ ઉપર શર્મા સાહેબ આ વખતે ઇન્ડસ્ટ્રી 4.0 which is an elective subject we have offered to students, and approximate number of registrations in this particular subject is 25. So at any point of time maximum students 25 થી વધારે તો નહીં જ હોય. So એના માટેની આ એક એક્ટિવિટી છે જેના માટે I am sure કે this is the first lecture but will not be the last one.
Definitely we will have many such interactions.
Sure. એટલે એવું અમે expect કરશું કે like some of the expertise from GEC Rajkot on machine learning, and we have artificial intelligence and machine learning again as an elective subject which is offered to the 6th semester students.
Machine learning is area in which I have done my PhD.
Oh, great.
My PhD is in machine learning.
Acha. So we expect some sort of an interaction between these two colleges will help my students particularly.
So this would be like the first pedagogy interaction, and I hope in future I'll come with more customized content, because this is a very general content I have drafted. But we can customize the content also, keeping the points in mind.
Sure, we can do that.
Sarma sir already briefed me regarding the part, but then I thought first interaction should be a bit general one, because
એટલે actually શું છે કે industry 4.0 માં આ students એની પહેલા કદાચ મને લાગે છે કમ્પ્યુટર બેઝ સબ્જેક્ટ આવ્યો હશે, PPS આવ્યો હશે, અને એ પછી કદાચ cloud computing I'm not sure કે because Sharma is teaching that particular subject, it's all together whatever you will take it will be new things for them. એટલે you start with the basic part. અને ચિરાગ થોડુંક એવું assume કરજો કે the inclination of my students towards the cloud computing, it would be as good as Neil.
Sir, I would be covering very basic aspects of cloud computing, and then only I'll enter the area of the role of cloud in industry 4.0.
Okay.
But before that, let me congratulate you also that what practice you have started is the combination of, because we all are conversant with the NBA, OB terminology. So this is the best part of combining curriculum gap plus content beyond syllabus.
True.
So it's double bonanza kind of, that you are on one side you are addressing content beyond syllabus, vis-a-vis you are also trying to inculcate curriculum gap. So this is really good.
And actually what we have been doing is we are inviting the experts in the domain, like you are invited today. So maybe not this semester. This semester Sharma would be in touch with you, but next semester some of the faculty from my department taking in another subject, like you said, you have done your PhD in the machine learning. So I'm sure Kamakshi in future would be, Sharma will pass on your number to her and she will be in touch.
Definitely. I would be pleased to take even 7 to 10 sessions with VGEC IC department students in
and Chirag, in future if this corona pandemic allows the student to come in the offline mode, so we would surely appreciate that, because sometimes teaching online
we have some official matter also. So even if online, it's fine. That's okay.
No. But what actually we are facing a issue like online students, because as a teacher, when you teach in the offline mode, you come to know, looking at the faces of the students, whether they are getting what you have been, means you are going in a proper direction or not.
Yes.
Offline, online, many a times students do not respond if you want to interact with them. So like subject expert like you, if you are available, so we'll surely try to have some of the sessions in the maybe hybrid mode, or if I would prefer to go for offline.
Sure, sir. I'm always at your
Sure.
disposal. Yes, yes.
Sure. Sharma, number of students have joined. Chirag, થોડુંક મારે કામ છે એટલે I would be leaving the meeting. Sharma has started recording that particular thing અને પછી Microsoft Team ની Sharma link share કરી દેશે. Professor, I invite Professor Sharma to give a formal introduction of Dr. Chirag Thaker.
Sarma Sahib. સર તમારો અવાજ
ચિરાગ શર્મા સાહેબ ઓડિબલ છે?
ના હવે ના નથી, હજુ સુધી નથી.
વેઇટ, એટલે શર્માએ ઓલરેડી ઇન્ટ્રોડક્શન શરૂ કરી.
શર્મા સર મ્યુટ છે સર. સર હી ઇઝ મ્યુટેડ. શર્મા સર ઇઝ
Sharma, you are already muted, and unmute yourself and then start. Sharma, you come to my system. Chirag, just a second.
Are sir, please.
Sharma, here. Are you ready?
Hello. Sorry for this disturbance from my side. I think Chirag sir, I'm audible for all of you?
Yes, sir. You are perfectly audible. Please go
ahead. Okay. So, before not wasting the more time for briefing about our Chirag sir, I just brief very shortly. Dr. Chirag sir is one of the prominent academicians in our technical education department. And sir has started his career as an academician in 1998 after completing his graduation and joined DDIT in computer department. Then after his travel long journey to reach as a destination as a professor in our technical education department. He has served as lecturer in computer department in government institutions, started from Government Polytechnic Gandhinagar to lastly at LDC Ahmedabad. He's completed his PhD in 2013 from Gyan Vihar University, Jaipur, Rajasthan. Then after, he was selected through the GPSC as a professor and posted at head of the department at Government Engineering College, Rajkot. And still he's working as a head of the department at Government Engineering College, Rajkot. Dr. Thaker is associated with the G2 and under his supervision and guidance, more than 5 students are pursuing doctoral research. Professor Chirag sir, Dr. Thaker received various prestigious awards from eminent organization by contributing his best efforts in teaching. His area of interest are cloud computing, cloud security, big data analysis, and conventional AI. Now, without taking more time, I would like to welcome Dr. Chirag sir to start this expert session on the role of cloud computing in Industry 4.0. This lecture will be having 50 minutes of the time duration and remaining 10 minutes for the line interactive session with the student. I hope this lecture will definitely helpful to reduce the curriculum gap of Industry 4.0 and will enhance your understanding of Industry 4.0 domain. So I handed over this session to Dr. Chirag sir. Please, sir, we'll start.
Thank you, Sarma Saab. Thank you for this generous introduction. I have only one request, that you can call me by my first name, so that would be far suitable. Thank you, VGC Chancheda, specifically the IC department, for sharing this giving me this opportunity. I take this opportunity to thank Honorable Principal Sir and office bearers of VGC Chancheda, head of the department, IC, and able leader, Professor Dr. M.K. Shah sir, one of the finest technocrats in the IC department, and my dear friend, Professor Sarma sir, and all the faculty members of IC department. I also welcome all the students who have joined this session on the role of cloud computing in Industry 4.0. I hope I am audible and my screen is visible. Thank you. So let us salute Corona warriors. Since March 2020, what we have witnessed is unprecedented. And we not only salute the doctors, the paramedical staff, and the nurses and other people, we thank everybody who actually helped us to survive in this testing time. Be it municipality workers, the vegetable vendors, the policemen, the people who actually supplied goods at our doorsteps, all people. This is going to be the flow of presentation. I may not be able to finish it in maybe 50-55 minutes, but this presentation flow would talk about Internet Minute, digital life and geosocial universe. And then we will enter the formal subject called cloud computing, basics, characteristics. Then I'll discuss cloud service models and deployment models. Because cloud is a business model, and I always call virtualization is the driving force. So we have a couple of slides on virtualization technology and evolution of cloud. And then we will formally try to merge these two paradigms, cloud and Industry 4.0. Then after, I will have a couple of slides discussing basic thoughts on Industry 4.0. And then we will look at the driving technology, that is edge computing and cloud computing, Industry 4.0. And then Industry 4.0, many examples and some real-time life scenarios of smart factory. And then I'll discuss one interesting phenomena, which is called digital twin. So with digital twin, I'll try to conclude my session. I generally start my session with an acknowledgement slide. The presentation acknowledges content, especially images are taken from Google. There are many slides where the image source is written. There are many slides it is missing out. So the universal Google image URL is www.images.google.com. The images are used purely for an academic purpose. The presenter has no intention of copyright infringement. With this declaration, it is customary to start my sessions with some of the quotes, and this is from one of the finest brains the world has ever produced, Mr. Albert Einstein. He says, we can't solve problems by using the same kind of thinking we used when we created them. That means what he's hinting at, out-of-box thinking. The second quote is very much suited to today's talk. Everything that can be automated will be automated. This is from an internet law and policy expert, Mr. Robert Kennan. And another quote on this slide, which is visible to you, is the thing about smart people is they sound crazy to dumb people. So this is from Steve Jobs. Now, friends, what you are looking at, this screen is the world map, and it is based on the population. And you can very easily see that Asia is somewhere around 4.5 plus billion people. And Africa is 1.28 billion. And the American continent and the South American continent is somewhere around 600 to 700 million people. Now, out of this total around 7 billion people, there are 4.93 billion people, they use internet worldwide. And out of them, that is the total 63.2% of the global population. So one slide you may find 4.5 billion, one side you may find 4.63 or 93 billion. But anyway, more than 4.5 billion people, they are active users of internet. and that is the 63 or 60 plus population of the world. Now, what do they create? They actually create the geosocial universe. That is, there is 4.6 billion mobile devices globally right now active. And if you concentrate on this figure, Facebook, 500 million people, they access Facebook via mobile devices. And you can also see Gmail, 173 million, Yahoo, 284 million, Hotmail, 360 million, and all the data. Now, what do they create? This geosocial universe basically creates this divide. And the divide is very much visible here. So far as the market value in US $1 billion is concerned, US comprises the market share of 69%, and Europe comprises the market share of 4%. And in 2015, it was 3%. Asia comprises the market share of 27%, which was 28% in 2015. But here, the larger set of companies which are visible here are Tencent, Alibaba, Samsung, and other companies. India has to very actively put its footmark over here. Now, because of this, these 5 people are actually dominating the world economy. Not only the world economy, but the technological sphere also. So you have 112 plus million plus prime subscribers. So far as Office 365 plus is 360 is concerned, there are 200 million plus people, 1.5 billion active devices from Apple, 1.6 billion daily active users of Facebook, and 5.8 billion searches per day. Now, what do they create? They actually create this, and it is called digital life. Sarma Sahab, am I audible and perfectly visible? The screen is? Fine. Okay, Juvita. Thank you. Thank you. So this is digital life. And here you can see that digital life is very much integral part of our daily routine. And this has actually resulted in one phenomena, and that is our bandwidth appetite has increased many a number of times. And what you do is, after the proliferation of social networking sites, what actually we do is we are now the contributor community. So we are no longer the consumer community. So when the internet era actually started, the initial days of static web pages and dynamic websites, there were very few people who used to create content, and the rest of the people used to consume the content. So there were 7 to 10% people who used to create the internet content, be it a presentation or anything. And there were something like just a minute. There was something like there was something like 90% people who used to consume this internet. But because of the proliferation social networking sites, everybody is a contributor now. And because you are a contributor, you create a lot of data. And this is called big data. And it is in terms of petabytes and zettabytes. Now, what is a zettabyte? Zettabyte is 1 billion terabytes or 1 trillion gigabytes. I repeat, zettabyte is 1 billion terabytes or 1 trillion gigabytes. And now roughly we create 5 zettabytes of data. And where do we keep this data? So the data is hosted in cloud. The data is stored in cloud. And that is the first part of our session. So your digital life at individual level and at corporate level is creating a lot of data and related applications and platforms and programming environments and technological paradigms are very much part of our daily digital life. Now, what does it drive? It drives these 3 phenomena. It's called digitization, digitalization, and digital transformation. Now, there is a difference. What do you mean by this? So, digitization is nothing but the conversion of products to digital format. So, existing products are there. You are just converting them to digital format. And the commitment and invention is there. Now, digitalization is the business. It's the innovation of business models. So basically, now the innovative business models have come into picture and the processes that exploit digital opportunities. That is digitalization. And the next is digital transformation. And this is the era in which right now we are working at. It is the system level restructuring of economies, institutions, and society that occurs through digital diffusion. Now, because of this digital transformation, this is the internet situation in 2021, and it is called digital minute. Every 60 seconds, 28,000 subscribers watch Netflix. Every 60 seconds, 500 hours of content, that is the video content, is uploaded on YouTube. And every 60 seconds, 69 million messages are sent on Messenger and WhatsApp. And every 60 seconds, US people spend 1.6 million money on Amazon, online money spent. So this is the estimated amount of data that is created on internet in just 1 minute. And this is going on. It's 24/7 cross 365. Now, because of this, what you do is you generate huge sums of data. It's called the world of data. So there are 50 million tweets per day, and there are 24 petabytes of data per day processed only by Google. Keep the other companies aside. So there are 20 hours of video uploaded on YouTube every minute. So every minute, this much hours of video is uploaded. And data consumed by household every day is 375 megabytes. Every day, one household. So this is nothing but it's huge sums of data. And all these companies and applications and portals, they are all hosted on cloud platforms, and we call them cloud data centers. And in coming slides, I'll show you the cloud data centers, the actual images and all this. So because of this, there is two technology. Now, why the so much data is generated? Why the internet is everywhere? It is only because of two technology, and it is called ubiquitous technology. The dictionary meaning of ubiquitous is universal in nature. So there are two technology. One, telecommunication network, that is your mobile devices, mobility devices, and second is internet. And there is no boundaries between mobile devices and internet. In fact, the role reversals and intermingling of roles and responsibilities are very much there among these two technology models. And that's why what you do is, this is your daily routine. So you do a lot many media, you do consume a lot of content, you schedule your content, you sync your data, your likes, your dislikes, your photographs, your images, your daily routine, your content. So everything as an individual also you upload on the cloud. Now that is part of the cloud storage. That means this slide basically tells you that what we actually achieve is through various devices which is surrounded by us. We have generated one very big technological paradigm, which is called cloud. And cloud is a service-based model. Cloud is a business model. I call it business model because it's a multi-billion-dollar industry also. But cloud is basically a service model. So now we enter the era called the cloud history. So John McCarthy was the first person who introduced mainframe time-sharing systems in 1950s. And ARPANET from JCR Leclerc was introduced in 1969. And 1970, IBM 370 virtualization got launched. But the power of cloud computing was identified by Professor Ramnath Chelappa in 1997. And then Salesforce came, Amazon came. And now you can very well see that you have got PC cloud, you have got mobile cloud, you have got laptop cloud, and you have got tablet cloud. That means cloud is almost everywhere. It is virtually everywhere. Now, why cloud is virtually everywhere? This is the answer. This slide gives you the answer. Number one, it reduces infrastructure cost, that is compute, storage, and network cost. That is the actual infrastructure, which we call cloud infrastructure. There are three major verticals: processing or process vertical, storage vertical, and network vertical. Cloud gives you capacity and scalability. It is refreshing aging infrastructure. So it's one way to refresh the aging IT infrastructure. It supports new business opportunities. Business continuity is also supported. And another important point is there is increased collaboration potential in cloud paradigm. So now let us try to understand the definition of cloud computing. Cloud computing is a paradigm or a model for enabling network access to a scalable and elastic pool of shareable physical or virtual resources with self-service provisioning and administration on demand. So I can say that cloud is one of the utility services now, and that is a major breakthrough. Like electricity, like water, like pipe gas in your house, there is cloud services. So it is now an utility. So there is a possibility that you might not have seen, just a minute. Hello. કશો વાંધો નહીં, હું છે લેક્ચરમાં છું, પછી કરું તમને. હા. So, like we have utility services. See, perhaps you may not have seen how electricity is generated. You don't know anything about electricity production and transmission, but you are every day in and day out, you are using electricity. Same is with pipe gas or water and all this. Same way, technological domain, one utility service is nothing but the cloud service. So cloud is a paradigm that enables network access to a scalable and elastic pool of shareable physical resources. So there is no need for you to buy the actual physical storage or the processing power or the network devices. The cloud service provider hosts all these physical resources. They apply virtualization technology on these physical resources, and then as a utility service, it is given to you as on-demand services or pay-as-you-go model. So there is services for servers, storage, compute, database, analytics, intelligence. They all are hosted over the internet. And why internet? Because it is the ubiquitous technology. Instead of managing physical infrastructure yourself. So here there are two costs associated with keeping the physical resources at your premises or in your office. There is capex and opex. Capex stands for capital expenditure. The amount of money you have to spend to buy this storage or processing power or compute or servers or networking devices. So it is capital expenditure. And another one is operational expenditure. The expenditure which everybody spends while maintaining these devices, storage upgradation, cost of licenses, cost of application software licenses and all this. So it's called operational expenditure. And this is almost 20%. So instead of spending 100 rupees on keeping the in-house cloud actual compute resources or compute infrastructure, I can rent them, I can use them as utility services almost at the cost of 20 to 25%. And the major global players are Amazon is first company, Google, Microsoft. These are the major players who provide you the cloud service. So we call them cloud service. Utilities and capex and opex. Once we understood, now we enter the slide in which you are the last mile consumer. And internet service providers and all this gigabit networks, internet service providers, it is being given to you as last mile connectivity. And access network and wireless technology, they actually hand in hand to make sure that all these cloud related services, applications are being accessed by the end users or the last mile user. Now, once you understand that from cloud to your end, how actually it comes, now we can understand the essential characteristics of cloud computing. So the first characteristic of cloud is it is on-demand self-service. So it is like the way we charge our mobile phones with various talk time schemes, roaming schemes, and all this. You can also access the cloud infrastructures. You can go for storage, application, development environments, server space, bandwidth, networking, routers, all this. So on-demand self-service. and it is pay as you go model or pay per use model. What do you mean by pay per use model? If I consume more electricity, I'll pay more bill. If I use more compute power or cloud storage, I have to pay more. If I use less cloud servers, or if I consume less cloud storage, I have to pay less amount. Ubiquitous network access, we already discussed this. It is universally network access. Anywhere in the world, you can access the cloud services. It is location transparent. When you write something in Google search engine, or when you do some kind of Facebook or WhatsApp related activities, or something on Microsoft or Azure platform, you do not know from at which place your query or your request is processed, which server is actually handling it. So it is location and transparent, and it is user transparent. So basically it is nothing but pooling of resources, and this pooling of resources is the mantra through which the cloud services are given to the end user. So that's why for cloud it is say one for all and all for one. So all the resources is one resources for the end user. That's how. Rapid elasticity. If I'm a data processing company, it is scalable in nature. Now, what do you mean by scalable in nature? If I develop a website and if I host on the Google Cloud platform or Amazon Cloud platform or Microsoft Cloud platform, or for that say any cloud platform, if that slide has 10 clicks a day, that is fine. The response time would be good enough. If that slide has one photograph of some celebrity or some important stuff, and that goes viral, and if one fine morning in 3 hours the same site has 3.5 million clicks, same, the response time would be almost the same. I repeat, whether it is 10 clicks per hour or whether it is 3.5 million clicks per hour, the response time from the cloud service provider or the company which is hosting your site, your website or your web page or your content page, the response time would be almost the same. So from 10 to 3.5 million, it is elastic in nature. And this is just the example of internet access. Same examples I can give for data processing also. Whether I process 5 megabyte file or whether I give them 1500 files, each of 1 terabytes. If I'm ready to pay as you go model, the cloud service provider will give me the same kind of elasticity. It is measured service with pay as you go model. So that is what I was talking about. The cloud service provider has a very agile and robust platforms through which they actually monitor and measure the cloud usage. And based on the monitoring part and measurement, they actually provide me matlab cloud user, the bill. So these are the characteristics of cloud computing. So one more time, if I expand previous slide, I can say that these are the features of cloud computing. We already discussed resource pooling. So all resources are part of the cloud data centers. They are pooled together, and to an end user, it is user transparent, it is location transparent, it is platform independent transparent, and there is very good service of interoperability. On-demand self-service, we know, easy maintenance because it is the header of the cloud service provider for upgradation, maintenance, and all the bug kind of debugging and all the activities. Large network access, availability. Availability, yes, it is. I have kept one special slide for availability. Automatic system. It is very much economical. I already told you that at the 20-25% cost of this operational and capital expenditure, you can manage the IT infrastructure resources, whether it is software, whether it is hardware, whether it is development environment, whether it is only storage. That's how. Security, yes, very good security models are there in cloud services. Pay as you go and measured service, we already discussed. So in a nutshell, I can say that cloud basically offers you what? They offers you best of the performance. It is reliable, it is very much secure, and the cost saving is there. Operational excellence is very good. Now, once you understand that, we are quite comfortable with the basics of cloud computing. But I already told you that the cloud is a business model. It is the virtualization technology which is actually driving the cloud. But cloud is a service model also. And that's why there are many types of services, but there are three major categories of services. One is infrastructure as a service, another one is platform as a service, and the third one is software as a service. Now, what do you mean by infrastructure as a service? This is service model. So compute, storage, or other IT infrastructure like network as a service is given to cloud consumer or cloud user or end user rather than dedicated capability. Same way, application platforms or development environments or middleware is also given to companies or individual users as a service on which developers can build and deploy custom applications. So if you are a company and you cannot go for very high-end servers to develop application software, what you can do is you can create the complete software stack. When I say software stack, physical resources, that is servers, RAM, storage, then development environments, then programming languages, database, application softwares, plugins, APIs, all this you don't have to buy. You have to just rent them from cloud service provider. And the renting of this complete development stack or software stack is called platform as a service. So the development environment or the platforms to create applications or to create softwares is also given by cloud service providers to developer companies or developers. Developers can rent them for 6 months or 8 months, which is the span of the software development cycle. And then they use this and they develop the applications or application softwares on these platforms. And that's why it is called platform as a service. And the third one is software as a service. It is end user applications delivered as a service. So all this Gmail and all this whatever we are using, they all fall under the category of software as a service. Like Google Docs is also software as a service. So if I sum up what I already told you, infrastructure as a service, it is hosting. So it gives you the computing infrastructure, whether they are routers, storage, RAM, servers, all this infrastructure, computing infrastructure as a service. Platform as a service. So it is for building. So if you are an individual or a developer or a company, you can have the complete platform to develop your applications or softwares using this platform as a service. So that's why the mantra is build. And the third one is SaaS, software as a service. It is for consume. So you just upload like Office 365 or Google Docs. So it is softwares or like Salesforce is one customer relationship management, this software. So it is called software as a service. It is for consumption. So now when I say the highest control is with IaaS, that is infrastructure as a service, and it is meant for system administrators. Platform as a service, moderate control over the cloud environment, that is for developers to develop and deploy the application softwares or applications. And SaaS is the least control so far as end users are concerned. Majority of the control lies with the cloud service provider, but SaaS is for end users. Now, I was talking about this control story. So this slide will actually tell you what do I mean by. So all the blue stuff that is managed by you or managed by the owner or managed by the individual or managed by the company. So if this is on-premise, so what is on-premise? If I have the applications, the storage, the server, if I have everything in-house or if my company is managing, then I am managing networking, storage, servers, virtualization, operating system cost, middleware, runtime environment, applications, application softwares, plugins, so database, everything I have to manage. That is on-premise. But if I, instead of on, and that's why the operational cost and capital expenditure and operational expenditure is maximum, because everything is hosted in your environment, everything is hosted in your premises, and you have to pay for everything: maintenance, upgradation, license fee, procurement cost, capital expenditure, operational expenditure, all. If it is infrastructure as a So now from on-premise, we move to infrastructure as a service. In infrastructure as a service, managed by vendor, matlab cloud service provider. So if you are having infrastructure as a service, what is managed by vendor? Networking, storage, server, and virtualization. Only these four components is managed by cloud service provider. Companies like Google, Amazon, Microsoft Azure, Google App, and they are managing. End users or cloud consumers, they have to manage the cost and well-being of operating system, middleware, runtime, data, database, applications, everything. But if you move from IaaS to PaaS, this is applications and data is only managed by you. Everything else from networking to data to runtime, that is the execution, is managed by the cloud service provider. So you have very less control compared to IaaS. But if you are consuming a SaaS service, that is like Google Docs or Salesforce.com or Office 365, everything is managed by vendor or everything is managed by cloud service provider. You are just consumer of that. You do not have any kind of ownership. And that's why your operational expenditure is little bit, your capital expenditure tends to zero. So networking, storage, server, virtualization, operating system, runtime, data, database, applications, everything is managed by the cloud service provider. So I hope this slide actually clears the complete cloud service models. And that's why I call cloud is a service model. Now, once you understand this, these are just the examples. So far as IaaS is concerned, or infrastructure as a service is concerned, the famous companies or the famous service providers are Amazon EC2. EC2 stands for Elastic Compute Cloud. EC2 times, so it's called EC2. Elastic Compute Cloud, Amazon EC2. Google Compute Engine, Microsoft Azure, VM, DigitalOcean, OpenStack, they are the famous example of infrastructure as a service. So far as platform providers or platform cloud service providers are concerned, AWS Lambda, AWS Elastic, Microsoft Azure App, Google App Engine, Heroku, OpenShift, they are the famous past examples. And so far as software as a service examples are concerned, Salesforce, G Suite, this is Google Suite, Microsoft Office 365, they are the famous example of software as a service. Now we come to cloud deployment model. How will you deploy the cloud? So one is private cloud. So it is cloud, but it is privately owned by a company or a giant conglomerate. And there are two types of private cloud. One is off-site private cloud, another one is on-site private cloud. If you are having your private cloud and HSBC Bank, say for example, is having the private cloud in its own campus, it is cloud, but it is in own campus, then it is called on-site private cloud. If you are having private cloud, but your private cloud is managed by Google, then it is called off-site private cloud. So private cloud leverages existing capital expenditure a little bit. It can also reduce some operational expenditure, but it is intended for a single tenant or single rent person. Public cloud is the other extreme example. It is managed by the cloud service provider. It shifts capital expenditure to operational expenditure, because as a cloud consumer, you do not bear a single penny of capital investment or capital expenditure. Everything you pay is only the consumption cost, the operational expenditure. It is offers as pay-you-go, that is utility billing model, and it supports multi-tenant model. Now, if the third one is community cloud. The best example of to explain community cloud is, suppose there is a pharmaceutical company which has the servers and computing capability and virological labs and all this, but they do not have the human expertise. And there is a research organization which has the best of the researchers, research people and research facilities. So this company, pharmaceutical company, and these people can make a golden handshake, and the cloud which they erect is called community cloud, in which it's the sharing of capital expenditure and operational expenditure, and it brings together various groups or organizations with a common goal. In this case, what is the common goal? Maybe COVID-19 vaccine or some another medical related stuff. Now, if I combine this private cloud or public cloud or private cloud or community cloud or community cloud or private cloud, it's called hybrid cloud. So it is nothing but it is bridges. It basically brings together these various cloud deployment models. So this is how the cloud is deployed. Haji sir. હા સર આવે છે પણ પેલું મારું VGC નું લેક્ચર છે ને હું પછી ફોન કરું આપને. હા સર. So basically, so this is how I deploy the cloud facilities. So we call them deployment models. So these are various slides related to the deployment part. So we already discussed them. Public cloud and private cloud, and then hybrid cloud. It combines features of both private and public clouds, and in this case, it is cost effective in nature. And these are various strengths of various cloud service providers. Now, what is driving this cloud is virtualization technology. So what is virtual, which is not physical one? So basically, this is our traditional architecture. In your traditional computer system, there is hardware, or above it, there is operating system, and above it, there are application software which are hosted. In virtual, over the hardware, you insert one layer which is called virtualization layer. And because of this virtualization layer, on the same physical machine, I can host multiple operating systems, and may not be the same one, may not be the same versions. So I can create multiple virtual machines on one physical machine. And that's why virtualization layer is nothing but it's a layer of abstraction. And what does it abstract? It actually abstracts the complete computing environment. And that's why you can have multiple virtual machines hosted over one physical machine. And this is the technology which is actually driving the success of cloud computing. And this is nothing but your hardware resources, and you have got many operating systems, and you have got the layer of virtualization. Now in this virtual phenomena, because they are virtual machines, even when they are in the state of execution, from one physical machine, they can be shifted to another physical machine. And it's called live migration. And because of this live migration, we can have this resource pooling possible. And because the resource pooling is possible, you can have thousands of servers like this. So this is the actual image of Google data center. And Google has 40 plus data centers across the globe. Data center is called the cloud data center. Why it's called cloud? Because there is no cloud as such. It is the actual physical hardware where your search queries, your Gmail and everything, your Facebook and everything is actually kept, processed, stored and executed. So your execution, storage, uploading, downloading, everything happens with such actual physical resources or in IT infrastructure. And that's why we call them Google data center. And one data center has somewhere around 1.5 million servers on these stacks. So this is the actual image of Google data center. Now, if you take, this is the actual data center which is hosting 2 million plus servers along with storages and networking and all this. This is, if I'm not wrong, this is Google data center. And this Google data center has more than 2 million. Friends, the cost of one data center is not less than $2 billion. And the operational cost of one data center is 35 to 40% is the cooling cost. So if your recurring cost of data center is, for example, let us say $100 million, 35 to 40 million dollar I spent only for the cooling cost. That much of heat energy it is being generated, and that's why carbon emissions and all these are famous examples. And that's why majority of the companies run their data centers on renewable energy or wind energy kind of facilities. This is the actual figure of Facebook data centers. In every single company which is very major global footprint so far as IT world is concerned, whether it is Apple or Microsoft or Amazon or Google or Facebook, they all have such data centers. Now, I told you one phenomena, it's called availability. So what is the advantage of this kind of hosted services or service models? So if any cloud service provider tells you, or even your in-house system, if it is 90% available, that means the application or the service would be down for 1 month in 1 year. That means 30 days down or outage time. It is called downtime or shutdown time or outage time. What do you mean by outage time or shutdown time? That much period of time the services would be down, or the application would be down, or the facility would be down, matlab shut down. So if somebody says 90% available, that means 1 month out of 1 year, if you accumulate the outage time, it is roughly 1 month. If it is 99% available, then it is just 4 days out of 365 days. It is called 2 nines. क्योंकि 2 9 आते हैं, 99. If any cloud application or in-house application per se is available 99.9%, then out of 365 days, it is only down. If you combine the downtime, it is 9 hours only. Out of 365 days, only 9 hours. If it is 99.99%, just under 1 hour, that even you cannot achieve if it is your resource, if it is your servers managed by your company only. And every cloud service provider at least offers these 5 nines, that is 99.999. A little over 5 minutes only, it is downtime. And if it is 6 nines, that's where Microsoft and Amazon are actually working hard in, and they expect that by 2025 they will reach this 6 nines. What do you mean by 6 nines? Their service could be down only half a minute in 1 year. And if it is 7 nines, it would be down only 3 seconds. So this is the availability phenomena so far as cloud service provider is concerned. So it is not only the cost saving. In fact, you are getting far more availability and other technical aspects when you are hosting your applications or building your applications or consuming the applications or softwares on cloud service provider. So now, once you have, why this is possible? This is possible because of 2 phenomena, either scale up or scale out. What is scale out? Scale out is you are adding more nodes, or you are adding more servers, or you are adding more storage of the same size. Only the numbers are increasing. It is called scale out. What is scale up phenomena? Scale up is you are adding more nodes, or you are adding more servers, or you are adding more memory or storage in a gradually increasing manner. So if it is scale out, if it is 2 terabytes of hard drive, then I'm putting 2 plus 2 plus 2. So it is called scale out fashion, so far as storage is concerned. If it is scale up, then 2 terabytes, then 4 terabytes, then 8 terabytes, then 16 terabytes. So it is called scale up phenomena. So the cloud service providers sometimes go with scale out, sometimes they go with scale up phenomena. Now, once we understand that, now we actually enter industry 4.0. So here, industry 4.0 is just one part of the whole. So IoT, edge computing, cloud computing, industry 4.0, they are not distinct islands. They are very much related. And why they are related? It is only because of this. Pre-internet era was human to human era. It was very much limited to mobile telephony and SMS. Then came smart networks, and because of smart networks, internet of content aya, that is WWW, and the services famous were email services, information entertainment services. Then came smart platforms era and services era. It's called internet of services. It is also conventionally called web 2.0. Isme e-commerce, e-productivity, all this came. Then came internet of people, that is social media, which I call proliferation of social networking sites. The examples are YouTube, Twitter, Facebook, WhatsApp, all this. And now comes Internet of Things, that is machine to machine, M to M, and it is called smart data and ambient context. And this is semantically structured and shared data. So basically what you have is, now we enter the second part of our stuff, and I have very limited time, but industry 4.0. So industrial 4.0 is all about cloud, big data, autonomous devices, IoT, and automation. And because you are automation students, I have customized some of the slides for you only. So this is the industrial revolution timeline. The first generation industrial revolution was driven by water and steam power, and there were mechanical systems. Second generation industrial revolution was driven by electrical energy and assembly lines. It's called second generation. The third generation industrial revolution is driven by use of IT systems for automation, and fourth generation is cyber physical systems and machine to machine communication. Now, keeping the instrumentation in mind, you can see electrification, utilization of electrical power, and digitalization, utilization of CNC data and robotics. And then the fourth industrial revolution is marked by connectivity, connection of production and information technology. So what is the part of this automation and connection? So stage one is sensors and actuators, whether they are wired or wireless. What are sensors? They sense the physical entity and convert it into digital entity. What is actuator? Rough idea, rough definition is, it is the other way. Sensors is conversion of physical to digital. Actuator is digital to actual action. Digital to physical, that is actuator. From that stage, we enter the second stage, that is sensor actuators and data acquisition system. Then we enter edge IT, and then we go with data center and cloud. So what is edge? Edge is nothing but localized computing at the device level, at the intermediate level. It is called edge computing or fog computing. So what is Industry 4.0? So Industry 4.0 is all about interconnection. It is merging of physical, digital and biological devices. It is all about information transparency, mass data transparently shared and easily accessible. High degrees of technical assistance, that is machines, robots, everything are working together for additive manufacturing and energy levels or energy sectors. Decentralized decision making. So if I define Industry 4.0, it is a fully autonomous, self-improving process of matching products, resources and work to the most appropriate resources. I repeat, to the most appropriate resources. So resource utilization, resource optimization is also one major drive. So Industry 4.0, the major features are, it is aware, intelligent, responsive and connected. Aware means smart products, access to conditional information and in environment. What do you mean by connect? Smart products are equipped with machine-to-machine communications that enables interaction and data exchange with cyber physical systems. Responsive matlab autonomous product adoption and internal, and it is very much adaptive to internal or external commands. What is intelligent? Autonomous decision making and self-learning capabilities and processes is called. So these are major features. So basically Industry 4.0 is woven around this four stuff: IOP, IoT, iOS and CPS. CPS stands for Cyber Physical Systems. iOS stands for Internet of Services. So Internet of People, Internet of Things and Internet of Services. When we put them together in cyber physical systems, what we create is an Industry 4.0 driven industry or company. So today our systems are like this: production, machine control, that is our robots, PLCs, then production control system, that is about SCADA, HMI, then manufacturing execution systems, and then ERP at the top of this. So this is a hierarchical model. Industry 4.0 would be driven by cyber physical system. It would be a decentralized modular building model, and it would be self-adapting, self-regulating and self-organizing. It would be flexible in nature. So what are the 6 design principles of Industry 4.0? So if I want to achieve in Industry 4.0 is not a product that I can buy from one vendor shop. No, it is not the case. If you want to create Industry 4.0 in your existing setup in an evolutionary model, these are 6 design principles: interoperability, virtualization, decentralization, real-time capability, service orientation, that is service-oriented architecture and all this, and modularity. So these are 6 design principles based on which you can create Industry 4.0. And this is how I create. So I have got the field level, factory level and cloud level examples. In field level, I can have edge devices, sensors, actuators and related stuff. And some of the devices may have localized storage, very limited one, localized computing capability. And if it is the case, it is called fog computing or edge computing. Then data to the cloud and this. So this is, if I expand this, this is the example. So edge computing is linking the benefits of local computing and cloud computing. And edge computing is very much required in Industry 4.0. Only cloud, because cloud is at the remote place. It is at farther place. But if I have many sensors, many actuators, many elements or many parameters if I need, so I have to go for localized processing, localized pre-processing, some kind of executions, localized storage, and then sending it to the cloud. So this localized environment or the near to the actual sensors and actuator environment is called the edge computing. So what is local computing? It is once installed, it is rarely or never updated, and data transfer by USB stick or local network. Cloud computing applications are installed and executed on demand. It is a central data and global intelligence. But there are two issues: low frequency and sometimes high latency, delay. But edge computing apps are installed and executed on demand. There is local data, there is local intelligence also. So here you can see that there is a controller, there is a machine and edge device, and this machine and edge device are very much connected to the controller, and localized computing and data is managed by these edge devices, and then after the final results or accumulated data is shifted to the cloud environment. And that's why it offers high data volume and low latency. And low latency is the driving force so far as Industry 4.0 is concerned. So again, edge is sitting between the sensors and controllers. IC students can very easily understand the sensors, actuators, controllers, and various systems and platforms. And you've got the cloud for global storage, global execution, and other application part. But you've got one intermediate layer which is localized storage, localized processing, and pre-processing capabilities. It performs data caching, data buffering, data filtering, optimize M2M communication, data visualization, basic analytics. All these capabilities are at the edge level. So cloud computing and edge computing. In cloud computing, computation can take place only at the cloud level. So whether it is car, camera, traffic signals, or mobile devices, all the data is captured. They are stored in the cloud, and only cloud it is possible. But in edge computing, there is an intermediate edge server or edge capability, and this edge capability is used for intermediate processing or intermediate storage and related stuff. So if I give you the example, hospital and clinic, hospital is or cloud computing. That is, location is very good, convenience is good, service coverage is excellent, convenience is little bit less. But if it is edge computing at clinic level, I can say that location 5-star, convenience 5-star, and service coverage is 2-star. Now I come to the actual industry environment. So actual industry environment, if you look at Industry 4.0, you've got big data for storage and cloud. So that is high performance computing. But as an IC student, when you focus on the actual company hierarchy, you've got the factory floor. It is called component level. Then you've got PLCs. It is called the field level. Then you say SCADA or HMI. It is operation and control level. And then you've got MES at plant level. And then ERP at the enterprise level. Now, if we want to see the actual example, this is advancement in AI computing, that from cloud, we are now to the edge computing, which is tomorrow. So these are the 5 advantages of Industry 4.0. Lower latency, increased cyber security is very much secure. More manageable data analytics is supported by Industry 4.0. You can expand your interoperability. So that is one advantage of Industry 4.0, and reduce storage cost. So these are all benefits of Industry 4.0. And that's why it gives you Industry 4.0 framework. Now this framework is all about big data, IoT, augmented reality, cyber security, cloud computing, and additive manufacturing. Now what do we mean by this? It is this, Industry 4.0 smart factory. Now what do we mean by smart factory? In smart factory, there are various flows. One is material flow, which is given by dotted lines. Another one is two-way, machine to machine communication information flow. And there are cyber physical systems, and there is machine to machine systems. And friends, you can very easily see that there is a customer order and there is a processing capability. There is cutting station 1, cutting station 2, and cutting station 3 with their individual capabilities. One have 50, another one is 150, and one is 30. And they work in closed loop system to go for optimized processing. So this is the example, elaborated example of the previous slide. Here it is the factory of the future in which you have got digital guidance and digital twins. We'll discuss digital twin. What is a digital twin? So this is a future smart factory. The advantage of smart factory or the future factory is it can eliminate 45% of the global emissions. And this is the actual working. This is GIFs of how actually Industry 4.0 factories would work. Here you can see the assembly lines, how things are actually handled by people. There are very few people, but they all are connected and they all have this modular approach. So there are 7 major features of this smart factory driven by Industry 4.0. Number 1, robotics. Number 2, cloud computing services. Number 3, big data technologies, including big data analytics. Number 4, embedded systems for control and monitoring. That's where your SCADA and all this comes into picture. Number 5, wireless communication techniques. Number 6, smart storage. Number 7, flexible and intelligent logistics systems. So these are the ingredients of a smart factory which is being erected using Industry 4.0. And that's why I said Industry 4.0 is not one product which you can buy from vendor. In fact, it is the culmination of all these technology paradigms and services and facilities which you can put together just to create a very good environment. Now, once I do that, this is the real-time deterministic Ethernet. It is connecting everything. Here you can see PLC and distributed control system on one side. There is a condition-based monitoring. There are robots. There is smart automation. There is robotic and motion control robot. There's intelligent edge nodes. There is smart mesh for industrial stuff. There are robots and cobots, and there are very few people who are actually working. So this is the actual scenario. It's called Industry 4.0 scenario, which has been driven by edge computing and cloud computing capabilities. And I cannot say only edge computing and cloud computing. There is cyber physical systems. There are other aspects like 5G technology, connectivity, wireless technology, distributed control systems, PLCs, condition-based monitoring and control. Robotics is very much part of it. Automations and controllers, actual hardware devices, robots, they all are very much part of it. So it's the complete ecosystem. So Industry 4.0 is not, it is a complete ecosystem which you can create. And what are the benefits it provides? Flexibility, efficiency, communication, safety, and security. And if you zoom any corner of Industry 4.0, you can see the perfect synergy, the robots and the smart mesh robo is working. So factory of the future has these 5 major phenomena. And if any of the phenomena is missing, you cannot say it is Industry 4.0 factory. Integrated industrialization. Number 2, smart quality. Adaptive quality. Quality aspects are adaptive in nature. It is a very major breakthrough. Even if you are working for a FMCG company, smart quality is something which is very unique. Connected teams and operations. Everything is connected. Connected equipment and plant. And real-time data-driven supply chain. It is very much data-driven. So there is minimum yield and there are no need to keep very large warehouses where the produced goods will be kept. So this is smart manufacturing facility where your raw materials are collected from industry suppliers. There is a very good distribution center. There is retail. But here the eye-catching part is real-time decision making. So the shop floor, the analytics part, and the actual marketing and sales people, they are very much connected. And it is real time. They help them to create real time decision making process. Now I come to the last part of my talk. It's called digital twin. Now digital twin is a concept made up of cyber physical system. So what do you mean by digital? So there are physical aspects. There's a physical which is made up of sensors and actuators. And there is a digital counterpart of sensors and actuators. So what are those digital counterpart? Data and analytics. So along with sensors and actuators, which are the physical devices or physical components, there is the digital counterpart, data and analytics. So this digital has aggregate function, analyze function, and insightfulness. And the physical components has create, act and communicate. Now, once I combine them, I create a digital twin. So a digital twin is nothing. It is a virtual representation of a physical asset. So if there is a physical machine, the physical machine remains. But you create one digital entity, one digital model, one digital 3D aspect of the same physical machine with virtual representation of all the physical assets for that machine. So let us try to understand the attributes of a digital twin. It represents a unique physical asset. It is associated with a single specific instance of a physical asset. Suppose you have 10 machines. So at a given time, it is only specific instance, specific copy of one physical asset. It is continuously collects data through sensors. It is continuously connected to the actual physical machine or physical asset. Here we call machine an asset, physical asset, updating itself with any change to the asset state, condition or context. If the asset state changes, digital twin changes. If the assets condition or context changes, the digital twin context changes. So it provides value through visualization, analysis, prediction or optimization. So technologies which are used to create digital twin are IoT sensors, VR or extended reality, XR, AI, that is artificial intelligence. They automatically analyze obtained data. It provides valuable insights and made predictions, and cloud technology. So IoT, extended reality, AI and cloud. When all these four technology aspects are combined for a physical asset or for a physical device, I can create a digital twin. And that's why we in social life we use twins word. It is called digital twin. So this is the underlying technologies of digital twin. So augmented or virtual reality, cloud computing, IoT, AI and APIs, they are very much part of digital twin. So these are the underlying technology paradigms or models which I use to create digital twin. But evolution of digital twin is not it's not skyrocketed. Basically, 1970 we had Apollo 13 mission. 1977 flight simulators came with computer simulations. 1982 AutoCAD is born. 83 to 2001 AutoCAD became de facto tool in newly all engineering and design. 2002 Dr. Greaves concept of a digital twin comes. 2011 NASA and United States Air Force papers on digital twin. 2015 General Electric's digital wind farm initiative. 2017 Gartner lists digital twin as top 10 technology trend, and 2018 digital twin in product portfolios of all major software and industrial companies. And this is how I create a digital twin. For every physical stuff like hardware, actuators, there are network devices, design, dashboard, analytics and simulation environment to create the software. And it is supported by data storage, data processing and data modeling. And it is called the middleware of the digital twin system. So for a CT scanner, this is the physical device. It is the actual CT scanner. There are sensors attached to it, and there is a lot of data collected. And this collected data creates digital twin. And this digital twin actually helps in terms of device diagnostic and prognostic. And it improves performance and design of the actual CT scanner. This is the digital twin of the oil exploration machine. This is the digital twin of the full steamer with analytical models, information models, 3D visualization, sensors, software-driven control algorithms, and virtualized stuff. So if I create a digital twin, what I have to do? I need CAD, I need software, I need sensor, security, cloud, actuator, AR, VR, simulation, AI, data visualization, data integration, and data analytics. And it is a 6-stage process. It is basically reflection from the physical world to the digital world, and it is a reflection from the digital world to the physical world. So for a steamer or for a submarine, a digital twin is created. How it is created? Create virtual product. Number 1. Number 2, analyze, integrate, and visualize data. Number 3, simulate the behavior, the actual operations, the behavior of a steamer or a submarine in the actual environment. Control the behaviors, then communicate with virtual products, and then measure the actual data. So here in the screen, you can see the machines are there. There are multiple copies of the same machine, but one digital twin of the same size, same phenomena is created, and it is illuminated. This is the digital twin of a meter reading facility. And this is how, once you have created digital twin, because it's an abstraction level, I can do many experimentation in an isolated environment, and I can also sense the data, I can collect the data, I can do the analytics. So actually, before putting the actual practice on the shop floor, I can run so many simulation parts, so many operational or manufacturing part using digital twin. And even after, and I can guarantee that yes, this would be the product quality, and then I can give the commands to the actual physical machine. So I have almost reached the last slides. The UK manufacturing sector already employs 71 robots per 10,000 employees. And that's why you can see that there are many jobs which robots are actually taking in. And that's why we have to adapt. We have to adapt as academicians also, as students also, as technocrats also. We have to adapt these new phenomena, and we have to embrace ourselves with newer technology aspects and better abstraction and software related stuff like digital twins or industry 4.0, where our significance as the industry drivers always remains. Thank you very much. We are at the cusp of the fifth industrial revolution. And this is the last thank you slide. I'll say that it's Victor Hugo's statement: he who opens a school door closes a prison. If there is more crime uh, in the society, if there is more wrongdoings in the society, we should not go for more traffic police or more police stations or better courts or more lawyers. Rather, we should open a school so that the crime gets. So we should always attack the root cause of the issue. If more crime in society is the symptoms or phenomena, the root cause is the ethics part, the social society, the societal upbringings. So he who opens a school door closes a prison. This is a quote from Victor Hugo. Thank you very much. Thanks for your patient listening. Thank you.
Yes, sir. Hello. Yes, sir.
Thank you.
Thank you very much, sir, by sparing your valuable time and sharing very good information. Every slide of your presentation having at least one lecture content. But I hope my students really enjoying your all presentation, and then they enhance their understanding to learn this industry 4.0 as a base subject, elective subject in their curriculum, as well as for their technical knowledge. So on behalf of the IC department and faculty, students, and our college, we thanks again Dr. Chirag sir. Thank you very much, sir. Okay, sir. But due to some short period and due to some time shortage, can you make some more lecture for our these students which selecting this subject?
Sir, I can definitely, but because this is going to be this is my first interaction with your students and with your department.
Yes, yes.
Now, what we can do
Yes,
is
sir, yes,
I can definitely take many lectures if the demand is there from either the office bearers or the student community.
Yeah.
I can definitely do it.
Yes, sir.
But what we can do is perhaps I can put more content which is custom made content, keeping your syllabus or syllabus points in mind.
Yes,
Because
yes, sir.
this is very general aspects,
Yes,
like what is a cloud,
yes,
what is
your,
industry 4.0,
but,
how they merge. So this has been a very
yes, sir.
very general one. But yes, we can definitely
Yes, sir.
make.
But okay,
Yes,
actually, as a subject teacher of the, I find out some curriculum gap, right? So in this curriculum gap, we would like to conduct some more sessions like on the big data, then data analyst, right? So I make touch with you, and whenever you are available, so I definitely make some more expert session with you on benefit of our students, sir. So thank you very much, sir.
Sir, the only request I have is just try to have the genuine feedback from students, because if the
Definitely,
students
sir.
give me
Definitely.
goody feedback, perhaps it's not going to serve the purpose. So what I expect is very genuine feedback from the student community. And then what, as I
Yes,
told
sir.
you,
Yes,
that
sir.
if you give me very specific topic and very specific points, then I can keep like 10 slides per point. So it would be more
Yes, sir. Yes,
like,
sir.
yeah, that way.
Actually, sir, this is my first word. I introduced you as one of the prominent academician in our technical education department. So you prove yourself, right?
Sir, it is
Okay,
your
students.
love, affection, and generousness that you use these kind words for me. We are
Okay,
just
sir.
learners, and I hope please try to
No, no,
collect
sir.
very
It's
genuine
our
feedback
pleasure,
from
sir.
students.
It's definitely, sir. It's our pleasure, sir. Because you are sparing your valuable time. During this lecture session, you are attending 3 or 4 calls. Okay, no problem. Students, have you any doubt? Yeah, you want to ask something to our expert?
Yeah, is
Hello.
there any query, any suggestion, any critical
Any
comment?
doubt, any
Please share
suggestion?
openly. It would be a learning experience for me also.
Yes, sir.
And
Yes.
I thank the organizers, especially the department authorities, for giving me this opportunity to interact with you. It's been really a great learning experience, and I hope
Yes.
I can improve upon.
Anybody from anybody who's online? Nainraj, Juhi, Komal, Jyotika. I think Jyotika.
Jovita.
Hello,
Jovita. Sir, Jovita is my PhD scholar.
Jovita.
Jovita is my
Okay,
PhD
okay.
scholar, and she is actually live
Right, right.
streaming this also on YouTube.
Okay, okay, okay.
Uh,
Saurabh.
she is faculty with LJ University, and very committed and dedicated PhD scholar, and she helps me in live streaming this all my sessions, whether it is IIC sessions,
Okay, okay,
technical
okay,
sessions,
okay.
or expert sessions, all webinars. Thank you, Jovita. Thank you for being there and helping me. Yeah.
Thank you. So there are no doubt. I think if
Either
there is
they
no
all are
doubt, so
convinced or they all are confused ones. I don't know,
no,
but
sir,
I
no, sir,
hope.
no, sir. As a being a teacher of this subject, the what information you have provided in slide is very helpful to our student to understand better about to the content what you deliver. Even though in every this slide you show some pictorial view, sometimes we have to describe our word picture, na? But by watching this slide, so many doubts will be clear, right? So that's why. So now, not wasting more time, I wish you all the best, sir, and we conclude this meeting, sir. Thank you very much, sir.
Thank you, sir. Thank you very
Thank
much
you,
for
sir.
giving this
Thank you, sir.
opportunity. Giving
Are
this
sir,
opportunity.
are sir,
Thank you.
sir, it's our pleasure, eh? It's our pleasure, sir.
Thank you.
Thank you, sir. Thank you.
Okay.
Okay.
Bye, sir. So I'll leave the meeting. Thank you, Jovita.
Yes,
Thank
yes.
you all faculty members of IC department, VGC Chankheda. Thank you very much, Sarma Saab, a very close dear friend of
Yes,
mine.
sir.
Thank you very much.